Okay, so here's what 5.5 is about. Would you write this word in here? It's called the discriminant. Whoops, I got to spell it right. Okay, discriminant. Sounds like the word discriminate, which it is. We're going to talk about discriminate here in just a second. The warm up for each one of these said graph each function. So I noticed that somebody over here didn't graph them, but I think they got the number of solutions correct. It says how many roots. Okay, so I'm going to look at this. This is a parabola. It opens up. So a little bit of quick graph here. This moved it right 2 and down 4. So it opens up and the vertex has been moved right 2 and down 4. So it looks something like this. Doesn't have to be a perfect graph to answer the question. The question was, how many roots does it have? 2. Crosses the x-axis in 2 places. It's got 2 roots, 2 solutions, 2 x-intercepts, and so forth. Next one. This one, we took the graph, opens up, moved it left 3, stays the same basic shape. So we would go right 1, up 1 squared, right 2, up 2 squared, okay, so forth. On the other side, it's symmetric. So this one only has 1 solution. And when we look at this one right here, again, this one opens up, been moved left 1 and up 1. So it looks like this. Okay, now I just graphed those points right here. They look pretty good. I could label them if I wanted to, but this doesn't cross the x-axis. So how many roots does this have? 0. Doesn't have any. So what's an x-intercept? It's where the graph crosses the x-axis. So like by definition, if it's on the x-axis, the y-coordinate's got to be 0. It's where the function equals 0, which is again why we call them zeros. So when we're solving a quadratic function, what we're really trying to do is we're just trying to find where the parabola crosses the x-axis. Doesn't matter if they told us to graph it or not. In effect, that's what we're doing. And as we saw in the warm-up, there are 3 ways that a quadratic can cross, in air quotes, the x-axis. So it can touch the x-axis once, like this one right here. Okay? If that happens, we get 1 real solution. Okay, we'll often call that a repeated solution or a double solution in this case. Okay, some people say it touches or bounces. Okay, it can cross it twice like we saw in this example. In that case, we get 2 real answers. And if the graph does not cross at all, we get 2, what do you think? D? We do. We get 2 imaginary, or we could say complex, but we're going to say imaginary just to kind of rub in the idea that it's got an eye in it. It's going to have an eye, which is some of those illustrations that we watched earlier. Okay? So we're going to come down here and we're going to take a look at this. So if it has imaginary solutions, follow the logic here. If it has imaginary solutions, it's got an I in it. I is the square root of -1. So that means the quadratic formula must have a square root of -1 in it somewhere. Well, the only place it could possibly have a square root of -1 is that square root part with whatever's underneath. So this part, the b squared minus 4ac part, is called the discriminant. And it's called the discriminant because it helps us discriminate between how many solutions there are and what type they are. So the discriminant is this right here. So if anytime anybody in the future says, hey, what's the discriminant? You say the discriminant is b squared minus 4ac. And if you got numbers for b and a and c, you plug them in and you find the value of the discriminant. Okay? So follow along here. If b squared minus 4ac, or in other words, if the discriminant is greater than 0, which is another way of saying the discriminant is, what is it? Positive. Okay, it's positive. Then we get 2 real solutions. If it's equal to 0, in other words, the discriminant is 0, then we get 1 real solution. And if the discriminant is less than 0, which is another way of saying the discriminant is negative, because there's only those 3 categories. Those are the only possibilities for a number. It's either going to be positive, negative, or 0. Then we get two imaginary solutions. Okay, got it? All right, so before we go any further, I just want to make sure we're all clear on this. What are the other names for solutions? Colson, give me one. Roots. What's another one? Yeah. Zeros. What's another one? X-intercepts. Okay, so that's what we're trying to find here. So we can use those interchangeably. So on this one, it happens to say this. Now, I think yours might be slightly different, but we're going to make sure that we do this. We're going to determine the number and type of roots, and we're going to state the sign of the discriminant. Okay? At the very least, that's what we're going to do. So if we've got a graph, it's a piece of cake. Well, there are two real ones. I can look at them right here, right there, and right there. They happen to be ugly numbers. I don't care. They're two real ones. What about the discriminant? What do you know about it? I don't know A, B, or C on this one, but I do know that I've got two real roots. Look up above in that box. What does that mean, Zach? It's greater than 0, or in other words, it's positive. Take a look at this one. What about the roots? What about the zeros? What about the x-intercepts? No. So what does that mean? Two imaginary ones. So we're going to say two imaginary. Discriminant? It's going to be negative. You do the last one. We need to know the number and type of roots. And we need to know the sign of the discriminant. Mason. So it's got one what type? One real root. Okay, that's part of it. And the discriminant, can you tell us about the discriminant?
It is going to be 0.
It's going to be 0. Yeah.
So like on that one, the first one,
Uh-huh.
the parabola was flipped, would the answer still be like the same?
You mean if the parabola was up here?
Yeah, but it still crossed the x-axis.
If it like literally just like a complete vertical flip, like the black one that I've drawn right here? Yes. So yes, it would be. Mm-hmm. Yep.
Good question.
Great question. Okay, so let's take a look down here. Okay, if we don't have a graph, it is a little bit more difficult. It's not the entire quadratic formula. The only thing we need to compute is just the discriminant. And if somebody says discriminant, what do you automatically think? B squared minus 4ac. So we're going to compute b squared minus 4ac. So I'm going to do, notice that it's all set up for us. B squared is going to be 4 minus 4 times a times c. So even here, okay, this is the work that I would show. I'm going to say, hey, b is the 2. I'm going to square that, I get a 4. I'm going to write down negative 4, and then I'm going to do a, negative 1, c, negative 5. It's going to be 4. Am I adding or subtracting? I'm subtracting. I need to know how much I'm subtracting. I'm subtracting quite a bit. I'm actually subtracting 20, right? So that means the discriminant in this case, we're going to write what it is. The discriminant in this case is negative 16. For this question, which one's more important? The sign or the number? Just the sign. So the fact that it's negative, what does negative imply? Less than 0. What about the roots? What about the zeros? 2 imaginary. Okay, so the sign of the discriminant is negative. I'm just going to circle negative 15 or negative 16 because we actually computed it. And the fact that it's negative means there's 2 imaginary ones. Okay, this one's all set up. Go. Give it a shot.
Go.
Just to yourself, please. Yeah, I'm probably grabbing a calculator too. I do know for sure that I'm subtracting something, right? And however you want to multiply these, how much are we subtracting? 144. So we get 0. So it's 0. What does that imply? What does that tell us? What is it? One real, what words could we use here? Solution, x-intercept, root. I think they call them roots or whatever. Okay, so one real, solution, root, 0, anything like that. Okay, everybody good there? Mason.
So the discriminant is the zero's x distance from the vertex.
The axis of symmetry, yes, if you thought of it that way. Yep.
Okay.
Has something to do with that anyway. Okay, take a look at this. I'm going to ask Samara. Samara, what's the problem with this? What would we not want to overlook? The 2's on the wrong side. I'm going to ask Wilson. Wilson, would we want to move this 2 over there, or should we move those 2 guys over there?
The right two.
Yeah, he's going to move the right 2. Okay. We had different definitions of right and left and which 2 and stuff like that. Anything I can do to make it so I'm plugging in positives is we generally make fewer mistakes with positives. So like the fact that this is a positive 1 right here. So this is going to be b squared. 4 squared is 16 minus 4 times a times c. Are we adding or subtracting? We are adding. Now here's where it gets interesting. The instructions just said find the sign. Do we really care how much we're adding?
No.
What we care about is the fact that no matter what that number is, the discriminant is going to be positive, right? Now, it happens to be a 16, so we do get 32. We're close enough and it's a small enough number that we can just write that. But what it asked for was, what's the sign? It's positive, and that implies the fact that we have 2 real roots, solutions, whatever word you want. X-intercepts, that's great. Okay? All right, everybody good there? Okay, would you fill out those blanks at the bottom? Read the words. There's a sentence there. Read it, and then fill in the blanks. Anybody think they know all the blanks? I see a couple people writing. 1 or 2 hands up. Okay, everybody look up here. Stop writing. Everybody look up here. Don't consult with your neighbor. You're consulting with me for right now. Just to be clear, this does not find the zeros for us. All it does is help us know what type we're looking for. So we didn't find a single answer on here at all. I don't know where those cross the x-axis. But what we do know is whether or not it crosses and how many answers we're going to find. Okay? So we need all 4 techniques for solving for quadratics. The first one is, somebody want to raise their hand and tell us what those S and R stand for? Yeah. Square roots. Okay? You can use square roots to solve quadratics. Next one starts with an F. Sometimes I call this the math F word. Andy? Factoring. Okay? So you can factor it. What's the next one, Si? Complete the square. What's the last one, Zach? The quadratic formula. Okay, those are the techniques we have for solving. The discriminant does not solve. All the discriminant does is tell us how many zeros we get and what type they are, how many roots we get. Okay? All right.